beginning it was a mess, but when we managed to get this away, to clean out the samples, we got really pure DNA, to manage to tell something about him and especially about his ancestors.
It is possible that the ancient astronauts taught the Egyptians that mummification was a way of preserving their genetic information in the DNA.
The day the ancient secrets of Egypt took a radical turn was when scientists finally unlocked the full genetic code of the young ruler Tutankhamun. For decades, he was a symbol of mystery, the boy king of the 18th dynasty whose tomb, rediscovered in 1922, yielded one of archaeology's greatest treasures. Now, the sequencing of his DNA has peeled back layers of myth and misconception, revealing intimate truths about lineage, health, ancestry, and the complex web of power that shaped his short reign. Before we start, smash the like and subscribe buttons for more updates. What once was legend is now data. From the preserved remains of Tutankhamun, geneticists extracted fragments of DNA that had long resisted analysis. Earlier studies had provided glimpses, a series of partial profiles, haplogroups, familial links, but they were incomplete and left wide gaps. The latest breakthrough overcame previous obstacles of contamination and degradation, applying new molecular techniques to reconstruct his genome more fully than ever before. This is not merely a matter of filling in missing letters of a life story. It is about rewriting the script of ancient Egypt's royal house, and with it, our assumptions about identity, heredity, and rule. The first revelation struck at the heart of his birthright. Previous DNA work had indicated that his father was likely the mummy in tomb KV-55, possibly Akhenaten, and his mother a so-called younger lady mummy in KV-35. The new sequence confirms those familial ties with stronger statistical backing. It also affirms that his parents were full siblings, the children of Amenhotep III and Taye, making Tutankhamun a direct product of the very tight royal in-house breeding practices which were designed to preserve divine bloodlines but now appear inescapably fraught with genetic costs. That finding alone changes the way we view the Amarna period and all that followed. The youth who ascended the throne in a time of religious upheaval, who restored the old gods after his father's iconoclasm, is now shown to have been a genetic experiment as much as a monarch. The royal lineage was not just dynastic, it was biologically contained, insular, and vulnerable. In his compact genetic code, one sees the convergence of power, divinity, and the biological hazards of incest. Beyond lineage lies physiology. The DNA sequence reveals a record of impairments and ailments, traces of a leg injury, evidence of walking difficulty associated with skeletal deformation, and the presence of malarial parasite DNA. For Tutankhamun, it means the boy king was not the robust young sovereign often depicted in gold and glory, but a young man weakened by birth defects, by persistent infection, by the frail architecture of a body built on royal privilege but compromised by its own design. These medical insights ripple outward. They recast the spectacular treasures of his tomb, the canes, the walking sticks, the faience images of him seated shooting arrows from a chair, as not just symbolic royal regalia, but literal accommodations of his disability and infirmity. The sequenced genome gives new credence to what archaeologists had long suspected. The royal elite, despite their opulence, were humans subject to constitutional fragilities, especially when their gene pool had been narrowed by generations of intradynastic unions, and then the ancestry revelations. Though Egypt has long been held up as a cradle of unique civilizations, the genome of Tutankhamun reveals a mosaic of affinities. His paternal Y haplogroup, his maternal mitochondrial markers, the regional signatures of his line, they all point to deeper and wider connections than purely Nile Valley isolation. Prior studies had flagged his haplogroup as R1b, commonly found in modern Western Europe, though the interpretative leaps were widely questioned. More recent analysis, though, tempers those sensational claims and situates his lineage in the Near East and North Africa, underscoring Egypt's position as a crossroads. Through the fully sequenced genome, scholars can trace migrations, admixture events, and interregional interactions with more precision. The boy king becomes a genetic gateway linking Egypt to its neighbors and challenging simplistic notions of ancient ethnic purity. What this means for Egyptology and our understanding of ancient leadership is profound. The royal house of the 18th dynasty is no longer simply a sequence of names and titles, it is a human network whose genetics now maps paths of inheritance, vulnerability, and rule. The sequencing forces historians to reconsider the narratives of greatness. Empire building, monumental architecture, and divine kingship rested atop bodies shaped by both power and biology. One immediate implication is on how we interpret artifacts. The treasures of Tutankhamun's tomb, chariots, golden masks, thrones, are often celebrated as symbols of triumph. But when paired with the genetic evidence of his frailty, they can also be seen as compensatory. Displays of power attempting to mask or transcend mortal weakness. The walking sticks, so many of them, can be read not just as ceremonial accessories, but as grave goods readying a king who may have hobbled on earth to stride in eternity. The sequencing also adds weight to narratives of succession and legitimacy. With his parents confirmed as siblings, the episode of his accession takes on new complexity. His claim to the throne was not just dynastic, but biologically inscribed. The in-house breeding that his lineage shows suggests that the link to the divine could be manufactured as much as inherited. The gods were in the genes, but also in the gamble of incest. That alters how historians view the stability of his reign, his vulnerability to palace intrigue, and the swift reversal of his father's religious experiments. Moreover, the broader Egyptian past becomes more readable. The genome of Tutankhamun, when mapped against other ancient Egyptian and neighboring genomes, becomes a data point in an emerging web of ancient population dynamics. It invites questions. How mobile were the royal families? How often did foreign alliances bring new genes? How did plague, disease, and physical trauma shape ruling dynasties? Tutankhamun's DNA becomes more than personal. It becomes archival. In education and public imagination, the sequencing shifts the figure of Tutankhamun. No longer just the boy with the gold mask, he emerges as a mirror of his dynasty's hopes and frailties. His youth, his sudden death, his largely ceremonial reign, these are no longer just historical curiosity, but expressions of a royal body behaving in accordance with genetics, disease, and mortal span. The sequencing adds depth to the narrative. This is a young man whose life was compressed into a set of biological and political imperatives. For archaeologists and geneticists alike, this moment is turning point. The successful sequencing of such a high-profile ancient individual signals that the field has entered a new era. Extracting meaningful genomes from remains historically considered too degraded, and doing so in politically and environmentally difficult contexts like Egypt, was once thought nearly impossible. Now, with Tutankhamun's genome in the public scientific domain, the door is open for more ancient royals, more commoners, more populations to be luminous again. The intersection of archaeology, genetics, and history is no longer the exception. It is becoming normative. It also prompts ethical reflection. These are the remains of someone once considered divine. Modern science peeling back his genome raises questions about consent, about the sacredness of remains, and about the ways modern knowledge can rewrite ancient lives. The boy king, whose mask is one of the most iconic images in the world, now belongs simultaneously to legacy, to science, to modern geopolitics. His DNA links past and present in ways that simple artifacts never could. In sum, the sequencing of Tutankhamun's DNA is not a footnote in Egyptology. It is a paradigm shift. The pyramid of knowledge built around him has been partially deconstructed and reassembled on a molecular axis. His reign, short though it was, becomes a microcosm of genetics meeting monarchy, of biology interfacing with divinity, of human fragility juxtaposed with imperial ambition. As the genetic fog lifts, we can see the boy king not just in gold and grandeur, but in bone and gene and illness and lineage. Each marker in his DNA is a clue to who his parents were, what health burdens he brought, how his body carried the weight of kingship. The artifacts become more than reverent displays, they gain narrative gravity, as one can understand the weight of each golden scepter as much as a burden of a leg fracture, of a malaria infection, of the cost of dynastic purity. From the intact tomb in the Valley of the Kings to the modern lab where DNA is sequenced, the journey of Tutankhamun's story follows a thread that binds dust to data, myth to molecule. In that journey, his new genetic identity alters everything we knew. Not just about him, but about the nature of Egyptian royalty, the genetics of power, the movement of ancient peoples, and the somatic reality of being a pharaoh. The mask remains, but the man beneath it is revealed in sharper relief than ever before. The revelation of Tutankhamun's full genetic sequence has also begun to redraw the map of how ancient Egyptian civilization interacted with the world beyond its borders. Genetic markers within his genome show traces of distant connections, threads that extend beyond the Nile Valley into regions of the Levant, Anatolia, and possibly the Aegean. These subtle genetic echoes support what archaeology and art history have long hinted at, that Egypt was not an isolated monolith, but a nexus of trade, diplomacy, and cultural exchange. The DNA of a pharaoh, preserved for over 3 millennia, now confirms that the lifeblood of Egypt's greatness flowed as much from foreign contact as from the sacred river itself. The realization that Tutankhamun's ancestry may have contained influences from regions stretching toward the Mediterranean and Near East reshapes how historians think about the concept of Egyptian identity. It dismantles the simplistic notion of a closed civilization and instead paints Egypt as an ancient cosmopolitan empire that absorbed people, ideas, and genetics from its neighbors. Every gene sequence adds evidence that ancient societies were far more connected than previously believed. The Boy King's DNA thus becomes a living archive of ancient globalization, a molecular testament to the mingling of peoples that accompanied the movement of gold, incense, and papyrus across the known world. The genetic sequencing also casts a new light on religion and divine kingship. In the traditional worldview of the 18th dynasty, the pharaoh was not merely a ruler, but an incarnation of a god. His physical form was thought to carry divine essence, a direct conduit between mortals and the pantheon. Now, the decoding of Tutankhamun's DNA challenges that mythic perfection. His genome reveals a body burdened by the consequences of human choices: incestuous unions, inherited disorders, exposure to disease. It suggests that divinity, once seen as pure and untouchable, was rooted in fragile flesh. The priests and artisans who immortalized him in gold could not have imagined that his sanctified body would one day be read like a biological manuscript. This tension between divine image and human frailty adds a tragic dimension to his story, a god king whose mortality was written into every cell. For Egyptologists, this new genetic evidence forces a reinterpretation of the political motivations behind such close-kin marriages. The drive to keep the royal line pure was not only a spiritual imperative, but also a political strategy meant to consolidate power and maintain control over succession. The pharaoh's bloodline was the backbone of legitimacy. Yet the very method designed to preserve divine authority introduced physical weaknesses that could destabilize a dynasty. Tutankhamun's fragile health, now confirmed through his DNA, may have curtailed his ability to rule independently, making him reliant on advisors and high officials such as Ai and Horemheb. These men likely understood that the Boy King's infirmities provided them with both opportunity and danger, a ruler whose divine status masked the vulnerability of his reign. The sequencing has also opened a new line of inquiry into the broader population of ancient Egypt. Scientists can now compare Tutankhamun's genome to those of other mummies and skeletal remains from different eras, reconstructing how the genetic makeup of Egyptians evolved over time. Early results suggest continuity along the Nile, but also episodes of admixture corresponding to invasions, trade expansions, and migrations. This dynamic picture reveals a civilization that was genetically diverse yet culturally cohesive, sustained by the unifying power of its religion, geography, and monumental statecraft. Tutankhamun's genome, therefore, is not an anomaly. It is a window into a society that balanced insularity with openness, tradition with exchange. The technical achievement behind this discovery also deserves attention. Sequencing DNA that is more than 3,000 years old demands extraordinary precision. Egyptian mummies pose unique challenges. Embalming oils, resins, and centuries of humidity all degrade genetic material. The success of the project depended on the use of next-generation sequencing platforms capable of amplifying minute fragments and reconstructing them through computational models. Researchers worked in sterile, high-security environments, donning protective gear to prevent contamination from modern DNA. Each base pair retrieved was cross-checked through independent labs, ensuring authenticity. The level of scientific rigor required is itself a marvel, symbolizing the union of ancient preservation and modern innovation. This breakthrough has implications far beyond Egyptology. It demonstrates that ancient DNA can survive even in harsh, arid environments once thought unsuitable for preservation. This opens the door to analyzing remains from regions such as Mesopotamia, Nubia, and the Arabian Peninsula, areas that have long been archaeologically rich but genetically opaque. Tutankhamun's genome becomes a proof of concept for reconstructing entire chapters of human history once considered lost to time. The pharaoh's body, long entombed in silence, has become a catalyst for a new scientific era that bridges archaeology and molecular anthropology. The sequencing also touches on art and representation. Artists of the 18th dynasty idealized the royal image. Elongated skulls, almond eyes, and graceful limbs appear in reliefs and statues from the Amarna period. For decades, scholars debated whether these depictions were purely stylistic or reflected real physical traits. Genetic and forensic evidence now suggests that certain features, such as the elongated skull, could have been inherited or influenced by cranial deformation associated with congenital conditions. The art of the period, therefore, might not be abstract symbolism, but a stylized reflection of the physical realities of the royal family. This reevaluation merges aesthetics with anatomy, giving the art historical narrative a biological dimension. Furthermore, the genetic findings allow historians to revisit the social fabric of the Amarna court. If Tutankhamun's parents were full siblings, it follows that the pool of potential heirs was dangerously limited. This would have intensified competition within the royal household, where bloodline was both the key to legitimacy and the source of fragility. Advisors and priests likely maneuvered carefully, aware that the next pharaoh's health could dictate the empire's stability. The scientific data thus feeds directly into political history, suggesting that the personal infirmities of one boy might have influenced the destiny of an entire civilization. One of the most intriguing results of the sequencing is its potential to connect Tutankhamun's genome to living populations. Modern geneticists can trace shared markers between the ancient royal line and contemporary peoples in Egypt and neighboring regions. These findings reveal that the descendants of ancient Egyptians are not a vanished race, but a continuum of genetic heritage that persists today. The pharaoh's DNA, though ancient, still resonates in the genetic tapestry of modern humanity. It serves as a reminder that the past is not gone. It lives in the cells of millions who unknowingly carry fragments of that same heritage. The discovery has also sparked renewed philosophical questions about immortality. The Egyptians believed that eternal life was achieved through mummification, ritual, and remembrance. Now, through science, Tutankhamun has achieved a different kind of eternity, one measured not in temples or prayers, but in data and digital code. His genome can be copied, analyzed, and preserved indefinitely, ensuring that his essence, stripped of mysticism yet filled with wonder, will outlive any monument. This intersection of ancient belief and modern science gives the concept of immortality a new and haunting relevance. The sequencing's cultural impact reverberates beyond academia. Museums and exhibitions now have an unprecedented opportunity to integrate molecular data into storytelling. Visitors can experience Tutankhamun not just as a figure of myth, but as a human being whose ailments, ancestry, and physiology are known in extraordinary detail. This humanization enriches the narrative of ancient Egypt, bridging the gap between the living and the long dead. It deepens empathy and replaces distance with intimacy, allowing the world to see that even the most exalted of kings shared the vulnerabilities of ordinary life. On a broader intellectual level, the project underscores the power of interdisciplinary collaboration. Geneticists, archaeologists, historians, linguists, and conservators had to merge their expertise to interpret the results responsibly. Each base pair of DNA only gains meaning when situated within the context of ritual, politics, and art. The sequencing of Tutankhamun's genome thus becomes a metaphor for unity, of disciplines, of eras, of the ancient and the modern striving together toward understanding. It reminds us that history is not static. It evolves as our tools evolve. The genetic decoding of Tutankhamun also reframes our understanding of time itself. For over 3,000 years, his mummified body represented a fixed moment in history, sealed, static, and immutable. Yet DNA sequencing has reintroduced movement into that stillness. The molecular information retrieved from his remains allows scientists to simulate ancestral migrations and biological changes across centuries, effectively animating the past. Through him, Egypt's history becomes a living continuum rather than a frozen tableau. The young pharaoh's genome functions as a bridge connecting the Bronze Age world with the present, where ancient bloodlines, diseases, and evolutionary patterns converge in modern research. This achievement also redefines the relationship between science and wonder. The tomb of Tutankhamun once mesmerized the world through spectacle, its treasures, curses, and myths. Now the marvel lies not in gold but in data. The beauty of discovery has shifted from gleaming artifacts to invisible code, from sacred texts to sequences of nucleotides. In that transformation, the boy king's legacy evolves from material majesty to intellectual illumination. His story, once told through carvings and relics, now unfolds through the universal language of genetics, an eternal testament that even the silence of the dead can still speak, and in doing so, change the story of humanity itself. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Tutankhamun's DNA finally being sequenced? We want to hear from you. Thank you for watching and see you next time.